I want to make a distinction between discrete variables and continuous. A discrete variable is separate and indivisible. So if I ask people how many children they have, how many cars they own, how many degrees, etc., in those cases, you can't list a fraction. Those numbers will always be whole numbers, and they're indivisible, as the name suggests. A continuous number is understood to be infinitely divisible. So someone may say, well, gosh, I'm 5'1", which is 61 inches tall, but is that how tall they really are? Might they be 60.98752 inches tall, or 61.03 inches tall, of course. And just like our weight, height may subtly deviate throughout the day due to humidity or swelling of the feet, or gosh knows what else is going on. So there are many things that we treat as continuous that may or may not be. But here's the definition. A continuous variable is where there's an infinite number of possible values that fall between any two observed values. So you may say you're 5'1", but in fact you're 5'1.03" or 5'0.97", something like that. Now, we often treat things that are strictly speaking continuous, let me take that back, that are by a strict definition discrete, but we treat them as continuous. One example, for instance, is money. You could argue that between the values of $0 and $10, there are only, 1,000 landing points, like $7.94 or $5.01 or something like that. There are 10,000 pennies you can land on. But we still treat those numbers as though they're continuous, as though they're infinitely divisible. So it's a matter of practical application. Generally speaking, everything that we do will be considered to be continuous, even if it's quiz scores or something like that would appear to be discrete, but we'll just sort of treat them as though they're continuous. So moving on to one other thing is real limits. If we're talking about something that is continuous, it'll have an upper and lower real limit. For instance, what's the lower real limit for an A? Well, the lower real limit for an A is an 89.5. If a student has an 89.5, I always give an A. So by the same token, what's the lower real limit for the value of 150? Well, if we're infinitely dividing, it's actually 149.5. I will round up 149.5, and that number for 150 will go all the way till 150.4 roughly. It extends to an upper and lower real limit. This upper and lower real limit suggests that the value is continuously and infinitely divisible. This distinction will be brought out in Chapter 2 when we graph continuous variables. When you graph a continuous variable, just as is shown here, the number appears in the middle, and the upper and lower real limit appear on the right and left side respectively, to show that it extends to the half above and the half below.